Hello. Happy Monday, everyone. Happy time zone. Welcome in to what did we rename it?
Introduction to something foundations. I can't remember exactly.
Introduction to
Introduction
security
to information
right?
security.
Yeah.
And it's trademarked. So yes, we will learn it. So hopefully everybody is having a good Monday. It's rainy and awful here in Virginia. I don't know what the heck is happening. Yesterday it was 80. Today it's in the 40s and it's raining.
Oh,
Like I don't remember a time like growing up or, in my entirety of living in Virginia, like that weather, like usually once it got warm, it just like stayed warm. And then we got into hot and humid season. But this weather this year is just nutty. Just
yeah.
going all over the place. It's like South Dakota weather.
I was going to say, it sounds like South Dakota.
I know. Maybe I am in South Dakota and like
Yeah.
I don't remember it.
It's very, very, very similar to what we deal with here. But
Yeah.
even here, it's weird. Like in the winter, I mean, there's always been fluctuations, but we would have days where the weather was like, amazing, like 70 degrees in, January. And then the next day it's -20, which is pretty crazy.
Yeah, see, I couldn't handle that.
Mishpa just asked about lab access. It's in resources, but you can follow the instructions here in this Google document to get you access. I know it says active defense and cyber deception, but it's the same. It's the same lab environment for all of those classes, and we'll be updating that here in a little bit. But yeah, I don't know. And it's also, I was talking with Eric about this. In the summertime, it does it similar, right? You'll have like really, really hot and then it'll drop super cold. Yeah. And apparently both of those conditions in winter and summer, that level of swing leads to crop failure and like having to redo seeds. So she's really worried about that as well.
Yeah. We usually here it's like once we get into the hot and humid, which is where I like to be, it usually just stays there.
Yeah.
I do. I'm a fan of the hot and humid weather.
I'm
not a fan of the cold.
I like hot and dry. Humid's hard because it makes my
clothes. You like dry? See, I don't like dry.
I'm a sweater.
Me too.
Yeah,
it's really
like when we're down in Costa Rica and stuff, I will acclimate after about a week, but that first week is like it's pretty rough.
Yeah.
Like, and you got to
the water weight you lose.
Yeah, there you go. That's it. Which leads to dehydration and headaches,
I mean, what could possibly go wrong?
Yeah, exactly. But I see we got people in the Discord server.
Yep. And Jesse, thank you so much for posting the link to our upcoming Threat Hunt Summit. That's going to be super fun. And we have post-summit threat hunt training classes. So please check those out as well. If you do go there and you look at the different classes, it might look a little bit different. We're transitioning to a new learning platform. So for those of you that have on demand already, or you paid the tier to get on demand, it's going to look a little bit different, but it's super exciting that we're moving over to Thought Industries. And I did my first demo call today on Thought Industries, and it was like, oh, wait a second, this is like so easy. So it's really intuitive and it's really clean looking. And so hopefully everybody.
So you know what I'm the most excited about for Thought Industries. Megan, I want to get your idea on this because you deal with kind of like the statement of work contracts.
Yeah.
Pen testing side. They're integrating a natural language chatbot. So with all the classes that we have, the customers can come in and ask a question and it'll show all the training modules that deal with that issue.
Yeah.
So instead of having
to be super cool.
Yeah, that's what I'm really excited about for that as well. So it should be pretty sweet once we get there. And then are we moving these classes on to Thought Industries? Because I know we're doing the Zoom integration.
Eventually, right now, the focus is, of course, moving our corporate customers over. So we're going to be doing things in waves. So our corporate customers will go first, then our subscription people will go. So whoever wins bingo
Full catalog.
on Thursday will get access to the new system. So that's going to be exciting. So, but you must be present to win. Okay. How do I, Daryl, can you get that question in Zoom?
There's a Zoom question.
Yeah. It's just how to get into Discord.
Oh, gotcha. Yeah, I got
you.
You
See it.
Yeah.
But hopefully everybody had a nice weekend, and happy Mother's Day to all the mamas out there. Hopefully your kids spoiled you. I have sons, so I pretty much watched beaches in my room by myself.
I like the, what was it? There was a mom on Instagram that kind of lost her crap a little bit, which, makes it to Reddit and everything. And she's like, I hate it. Like Mother's Day is literally where everyone's like, Mom, ignore everything. It's fine. And then all the work that they would do for like laundry or food or whatever now piles up to Monday. And they're like, you just take the day off. And I'm like, that was not my house growing up, man. Like,
oh, no.
Like even outside of Mother's Day, it's like you were doing laundry, you were doing dishes. It was not like, Mom gets a day off. It's like, no.
I know. It's called distribution of workload, or in mom terms, pick up your own crap.
Yeah. Did your parents ever do the thing where like they would try to get you to clean your room, try to get you to clean the room, and then you would come back and your room would be cleaned and literally all your toys on the floor were thrown away or donated to Salvation Army?
No. See, what happened with me is we just like our parents just ignored it because it was upstairs. So they would just literally they would just chuck stuff upstairs. So we kind of look like hoarders because like the top of the stairs would just have stuff. Like we had to climb over to get it.
I remember my mom went into my room, and this is when I was really young and I wasn't cleaning it. And she just went in and literally picked up everything. I don't know if she threw it away or if it went to Salvation Army. I think knowing my mom, it probably
got donated.
Me.
Yeah.
But she's like, either you're cleaning your room or I'm going to clean it.
Right.
You really want this to be you're cleaning your room. Like,
right.
Yeah, that I wish I could say that fixed me for life, but that did change my mindset on things.
It didn't change your mindset, but did it change the behavior?
I think it did.
Yeah, mine was that I had really long hair, which of course, obviously I still have trauma for it. That's why I have long hair now. My mom, because I wouldn't brush my hair, my mom decided to take me to get all of my hair cut off.
Oh.
So came back. So super fun Gen X trauma story. Came back from getting my hair cut. My dad says, "Who's this little boy that you brought home?" And so of course I go screaming, running to my room, and people jump out of my closet for a surprise birthday party.
Whoa.
So that was fun. Yeah. So Gen X was a different time. It was a different time.
Megan, you're a Zennial like me, right? Like you were born between 76 and 82.
No, 74. I'm a 74.
So you are a hardcore Gen Xer.
Yeah.
For some reason, I thought you were younger than me.
Yeah.
You're hardcore Gen Xer. The special one I was reading about is Zennials. Apparently, we're a different Gen Xer. I don't understand what the breakdown is, but it's now 10 o'clock. Are we ready to record this?
Yes, we are ready to start and get going. We will be around in the background. Hopefully everybody has a super fun time, and we will see you guys at the breaks or we'll be around on Discord. So see at the end of the day for Ask Me Anything. Bye.
All right. Thank you so much, everybody, and welcome to A Gentle Caring Introduction to Computer Security. My name is John Strand, and you're going to be hanging out with me for the next couple of days. Quick note, though, if you have any questions or anything, please go to Discord. Go to our Discord server. If you're on the Zoom side, that's awesome, but you still want to get to Discord. And there are a couple of reasons for that. Number one, we have the resources, and in the resources has the instructions to get our lab environment up and running. Number two, we also have the recorded archives of this class. So if you miss a section, you can still come back at any time and you can re-watch that section at a later date, which I think is really super cool, just because people have lives and that matters. I want to give a big thanks to the Cybercall, who are helping us level up the MSP industry. If you're with the MSP industry, if you could do me a favor, just type in MSP. That would be awesome. We love the MSP and MSSP brethren that are a part of this as well. So we greatly appreciate that. We also have a number of sponsors that in the past have gone through and given us some funding to support this cause, which I think is really, really super cool. We have Blackpoint, we have Ninja, we have Datto, Cisco, ConnectWise, Huntress, Pax8, Scout, Sophos, ThreatLocker, and True Methods. All right, so what exactly is this class? So this is meant to be a bootstrap security class. We are going to cover what works to actually defend a network, and we're going to cover the things that Black Hills Information Security loves to see and hates to see in a customer network. And we're going to cover 11 topics, and we're going to be covering what works, what stops us. Now, there are a lot of audit and compliance frameworks out there, NIST 853. We are going to tie to the CIS controls. I'm going to talk about that more here in a little bit. But the important thing to understand is that we aren't going to put anything in here that doesn't have a direct bearing in stopping an attacker from breaking into your network. Also, as much as possible, I'm going to try to sprinkle concepts of how to use artificial intelligence to help you in computer security. Now, I completely understand that there's a lot of people that are looking at what's going on with AI. They're kind of freaking out, justifiably so. And they are trying to figure out how to live in a world with artificial intelligence. And I believe that that is absolutely essential as we move forward. So we're going to be talking about how that works. It looks like we got Centaur is from the MSSP space. Welcome. We appreciate you as well. Now, here are the main things that we're going to be covering. Main things are going to be application allow listing, password controls, egress traffic analysis, UEBA, which is a fancy way of saying artificial intelligence and machine learning, advanced endpoint protection, logging, host firewalls, internet allow listing, vulnerability management, and Active Directory hardening. I'm also going to be adding in a little bit to cloud as well. We're going to be taking that. By the way, over the next couple of days, I am going to be modifying the slides. So you have the slides in resources, but I'm going to be modifying them. And as I modify the slides for versions, I will be loading them up in resources so you have them as well. Now, one that we're not really going to talk about much, that's part of what we call the atomic controls, is backup and recovery. We don't talk about backup and recovery because one should just be doing backup and recovery. You should just do that. That should be a thing. We're not going to get into a lot of data about that, but really a lot of what we see in the cloud is helping us deal with backup and recovery as well, which I think is pretty awesome. Also, as a quick note, at the end of class, we will be getting into an Ask Me Anything for roughly the last 30 minutes of class. Every single day, you can come in and you can ask me anything related to computer security, life, the universe. I really don't care. Just come in and ask. Question is, what is this course called now? It's like 3 different names. Pick one. I know, right? The one that's on the website is the right name, Roswell. If you go to the website, you look at it, that's the one that you should go with. Honestly, I can't even. We had to get away because we I don't know. Strand. What is it? Pay what you can. I think the official name of it is now. What do we got? That's not the right name. That needs to be updated. I'm sure some people have already got it on Discord. Information security core skills is what we have, which actually isn't a bad name. Like information security's core skills is kind of like SOC core skills. And yeah, that's what we have. And I'm thinking about calling it like my classes from here on out, like information security core skills with AI. Maybe that's what I got to do. But AI has just sucked up all of the oxygen in the universe over the past few months. But let's jump straight in. Now, we are not going to be covering step-by-step Windows. We're not going to be covering step-by-step Linux, TCP/IP, crypto, security models, the common body of knowledge, the NIST 800 series, data loss prevention, because that crap never works, or the exploit du jour, even though there are multiple exploits du jour that are happening right now. And I will be discussing Mythos and Anthropic and vulnerability analysis when we get to that section of the class. However, if these topics are like, well, crap, I want to know those topics, we do have another class called Intro to SOC Core Skills. We can get a link to our YouTube videos for the previous runnings of those classes. The Intro to SOC Core Skills classes are available on YouTube. So if you want, you can go check those out. And we will be doing those classes live because we like to do them live and we like to get things out there as much as we can. Now, why are we covering what we are actually covering in this class? Like, why do we have the 10 things that we have in this class, right? So we started tracking vulnerabilities in our pen tests a long time ago. We do over 650 security assessments per year, and we started tracking what would have stopped us. Like, take all of those critical vulnerabilities and all of those things that would have shut us down. What of those things that are in all these audit compliance frameworks that are out there would have successfully shut us down? And we kept coming back to the same 10 things, right? So that's what this class is built around. We want to focus on what actually works for stopping us breaking into an organization on that. Now, it took a little bit of unlearning. Especially when I get to the Center for Internet Security, we talk about like compliance and things like that. I've been part of some of those frameworks. And one of the problems that you run into with some of those frameworks is you get a bunch of us together. We have conversations about what is actually important for stopping an attacker. And we kind of get wrapped around the axle. And we lose focus on what truly matters for stopping attackers. So we really kind of took all of it and we tied it directly into what would stop a real pen test or a real hack. Also, we've tied everything back to MITRE because everything has to be tied back to MITRE by law, I guess, these days. So that's what we're going to do. All right, so let's talk about compliance and the controls that you have to work with. So if we're looking at compliance, there's a lot of documents out there. I'm going to go to CIS Navigator. Let's go to this. There we go. So if we go to CIS Navigator and I select mappings, this is just a handful of the different audit frameworks that exist in the industry. In other words, there's a lot of them. And if you're looking at it, you got, SOC 2, Cloud Security Alliance, Cyber Risk Analysis, Cyber Risk Institute, HIPAA, Microsoft Benchmarks, New York Department of Financial Services, FISMA, CMMC. You got a lot here. I think NIST is here somewhere. I'm not sure, but there's a lot of them that exist. Oh, there it is. NIST 800 171, right? And for Brian, time traveling nerd herder, New Zealand Information Security Manual, right there. Yeah, we got that. Now, the issue in computer security is that many organizations have to map to one or multiple different frameworks, right? And this becomes exceedingly difficult for many organizations to do, and it becomes incredibly expensive to do as well because you are constantly trying to cross-reference and deconflict the different automated standards that are out there, or the compliance standards that are out there. So what we talk about in the slides, and I have these predominantly as like backup slides, we're talking about the CIS controls and things of that nature. What we recommend is that you go to the Center for Internet Security first, map there first, and then you can automatically cross-reference to any of these other frameworks. So if I was going to go through and let's just go ahead and go to NIST. I'm a NIST shop. I'm going to choose those two, right? Like as I'm going to the various controls, it's going to show me how that control maps to the other controls, right? So if I did this one, establish and maintain a software inventory, maintain a detailed software inventory for all licensed software that is installed on enterprise assets. The software inventory must document the title, publisher, initial use date. And then it says, this is the mapping to those other frameworks, right? So if I meet the Center for Internet Security standards for 2.1, then I'm in compliant with the NIST cybersecurity framework, ID AM2, NIST 800-171, 3410, NIST 853, CM7, CM8, and MA3. Do you see how this is powerful and how this saves a tremendous amount of time for organizations? Because if you can do this, you don't have to create separate, like massive documentation that exists to be able to prove compliance with these various standards, right? Now, let me go a bit further. One of the things that I'm going to be talking about in this course also is using things like ChatGPT, right? So I've got my class project here, and inside of ChatGPT, and you can use Anthropic, you can use whatever you want. I'm just using ChatGPT because it's available, and I use it for like forward, like outside looking things. So if I'm writing, an article on pen test salary bands, or I'm doing write up on what is MIME types, what is gets and assembly, CVS, like that's what I'm using. Is I'm using OpenAI. You can take your compliance spreadsheet, right? Like I can take this critical controls spreadsheet, my compliance to the critical controls, and you can put it into ChatGPT, and you can say, I meet these compliance standards. How can you please create documentation showing how I'm in compliance with the NIST CSF, or the cybersecurity framework, right? So if we have a spreadsheet, you can say this is CIS, feed it into ChatGPT, takes it apart, and then it can kick out the documentation, and it can even do gap analysis for you on what these different frameworks are doing for you, right? So let me go ahead and stop sharing here real quick, because I think I have a spreadsheet. Let's just do a search and downloads, XLS. No, just downloads. Maybe I don't have one. I thought I had one. At any rate, so I was going to show you, I could pull down a spreadsheet and we could do like the mapping automatically. So let me reshare my screen. I can show you that here in a bit. I think I have it on a different system. But at any rate, you can go ahead and you can take that CIS, and then you can export it and it'll automatically map it. And this, well, I can do the export of the spreadsheet right there. So it'll show the export. There we go. I think it's opening. There we go. So here is the breakdown of the controls. So here we have the control number 1, and then here is the full mapping to the CSF, right? So you can have CIS automatically do this, or you could have ChatGPT do it. So what I would recommend you do is you actually put your compliance status like here, like an X, like for every one of the controls that you have met, like control met. There we go. And you could go ahead and just kind of fill that out, and it would automatically cross-reference you, and CIS automatically generates that spreadsheet for you. So it's almost like if you're looking at it, it becomes a Rosetta Stone for the critical security controls. And it's very easy then to take this, right, and take the critical controls and then cross map it. And the people at Audit Scripts did this a while back. Once again, ChatGPT is great for this, right? You just take it, say, these are the different compliance frameworks that we are in compliance with, and then what are the different attack techniques that we have neutralized because of the way that we have have implemented the critical controls as well. All right, so we're going to jump straight in, right? We're not going to be doing a lot of like, here's a command line, even though we do have a class for that you all can use. We're going to be jumping straight into application allow listing. Now, application allow listing is an incredibly powerful tool, but if you're looking at application allow listing, it's terrifying for many people because you have this idea in your head that what you have to do for application allow listing is go through and manually allow list every single type of application that you would have in your environment. And that sounds tedious. That sounds really hard. And while we're doing this, I'm going to close Excel and don't save that. And I'm going to go to my Cloud Labs. So once again, the instructions for getting into the Cloud Lab environment that I have right here is available in the resources section. You just go into Cloud Labs, you put in your access code, and then it unlocks the lab environment. But since we have a lab coming up and it takes about 2 to 3 minutes for it to start, I'm going to start my lab up. And we're going to get it running because we have a lab coming up at the end of me talking about this particular section. So application allow listing is designed to restrict which applications are allowed to execute on your endpoint. This is an incredibly important point. And the reason why it's so important is because if we can restrict it, it creates a much, much narrower pathway for an attacker to gain access into our environment. But there's right ways and wrong ways to go about doing this, right? If we try to just do it the traditional deny list way, where we're going to run through and we're going to try to identify every single application that is evil, and we're going to block those, then we're going to have a bad time. Right. And this goes back to Marcus Ranum's 6 Dumbest Ideas in Computer Security, where he said trying to enumerate badness, right? Like trying to go through and enumerate every evil application that exists on your system is an incredibly bad idea because the amount of bad applications that are released is far outstripping sometimes good applications that are released. Also, bad applications can be Trojaned or inserted inside of quote unquote good applications as well. So this deny listing methodology and this mentality that we have as humans is very, very, very common. There's a story that I like to tell. It goes way back to kind of articulate why humans are wired in such a way. I want you to imagine that there's 2 cavemen walking down a path. And by the way, it had to have been dudes. You'll see why here in a second. But these 2 cavemen, let's say their names are Ugg and Thug. Not now. There we go. Ugg and Thug are talking to each other. Ugg looks at Thug and says, "Hey, Ugg, you need to eat that mushroom." And Thug's like, "Dude, I am not eating that mushroom." And Ugg's like, "You should really eat that mushroom. You should totally eat that mushroom." Thug's like, "Nah, I'm not going to eat the mushroom because you tell me to eat the mushroom." And then finally, Ugg says, "I double dog dare you," or whatever the caveman equivalent of double dog daring was back then, right? Thug's like, "Well, now it's on. It's a caveman double dog dare." And he eats the mushroom and he dies a horrible death, like foaming at the mouth, bleeding from his eyes. It's really, really quite bad. And from that day forth, the village tells the story of Thug the idiot. And I'm going to translate it. It goes, "Thug the idiot ate the mushroom. The mushroom is purple with these yellow stripes. We don't eat the mushroom because we're going to die very painfully and poop ourselves in the middle of a path." Okay, 2 things about that. 3 things. Number 1, I had to translate it. Number 2, let's be honest, the music that they had back in the day, not as good as our music, right? There was no like caveman Beatles. The 3rd thing is human beings have historically looked at risk exactly like that through narratives and stories of deny lists. For years, and I'm joking about cavemen and women, but when cave people, what is that? Caveman lawyer from Saturday Night Live. When cave people would try to share information in the form of what to eat, what not to eat, what to do, what not to do, they oftentimes did it in song. And a lot of those songs would be this person did something stupid and died horribly, right? But it was a deny list. And a lot of these deny lists built up over time. Eat this, not that. Don't snuggle with polar bears, bears of any kind, bad. Don't go swimming with sharks and so on, right? You had all of these narratives and stories because the human psyche was wired for deny lists because it worked, right? Denialists work with the human psyche. And the reason why denialists work very well with the human psyche is because threats were static, and risks were static too, right? The idea of a mushroom that was poisonous would make sense because that poison mushroom wouldn't change the way it looked in the next day. It just wouldn't at all. It would stay that way for a long time. So the denialist works. Now, if you try to apply this denialist methodology and you try to apply it to the way that cyber works, today it may be a mushroom with yellow stripes, but tomorrow it might be a sizzling filet mignon. And that whole denialist methodology and the way of looking at risk as far as human beings are concerned is outdated, and it does not work. All right. So this also gets us into a slight problem of time to compromise, right? How long does it take for somebody to be able to write malware that allows you to bypass someone's computer? Well, I'm going to be honest with you. Getting initial code execution is still relatively easy on many systems. What is comparatively difficult is what happens next, right? Once an attacker starts using malware to laterally move or try to escalate privileges, a lot of security technologies that exist today are very, very good at detecting that. And getting that initial code execution and that foothold is still there. So we used to do a webcast called Sacred Cash Cow Tipping, where we would go through what are the ways that someone could bypass AV on a computer system. And we'd do a webcast and bypass all of the major AV vendors, and we would do it in like a day. Now, we did this because the industry was so wrapped up in AV and the belief that AV was the only solution to all of the problems that people had. A lot of this is through marketing that we had to counter program that. Right now, we stopped doing it. We stopped doing it for a couple of reasons. One, a lot of the techniques that we were using still worked a number of times. Number two, we didn't think that there was a lot of need because I think we got our point across when we were doing it. But there was a lot of different tools that allowed you to do this. So I mentioned Marcus Random and the 6 dumbest ideas in computer security. The idea of going through and creating baseline deny lists for the malware that's created, the idea of creating baseline deny lists for websites that people go to is one of the dumbest ideas in computer security because it's fundamentally rooted in the way that cavemen looked at the world, right? So we have to move past that. So I want to give you a couple of my favorite AV bypass examples, right? Now, if you try to follow these exact steps, AV is going to catch you. Understand that AV bypass is absolutely an art more so than a science. So if I was to give a class where I went through step by step how to bypass AV, it may work today, but it would probably get caught tomorrow. I'll give you an example. I was doing a lot of teaching down at Los Alamos Labs down in New Mexico. And I was also doing it at Sandia. I was training all the systems administrators down there a while ago. And I had a lab where it was like, here's how you bypass AV. And I found out what AV they used. And to get my point across, I think they were using Symantec. I'm not sure. It might have been McAfee. It was one of those two. This was a while ago. I had a lab of bypassing that AV. And they flipped out. Now, do you think that the people that were in that training, do you think that they took the message to be, hey, it's relatively easy to bypass AV and perhaps we shouldn't put all of our eggs in one basket? Perhaps we need to have a nuanced, detailed, and thorough security architecture that assists us with being able to deal with vulnerabilities and inevitability of our AV failing? Or do you think they said, oh my God, this lab bypassed AV, let's get it to McAfee or Symantec immediately so they can write a signature for it? Yeah, they did option 2, right? They did option 2. So this class, whenever we're using malware, we aren't going to be doing the lab to show you how to bypass AV. We're literally going to be disabling AV. Right? We're going to be showing you how to disable it to show you how to hunt malware. We're going to disable AV to show you the efficacy of using application allow lists. We're going to be using this malware specimens to articulate points, but those points aren't how to bypass AV. However, I want to share with you some of my historical favorites. One of my historical favorites is ghostwriting. All right. It's ghostwriting. when you're looking at this, there's a couple of reasons why this is incredibly important to try to understand what ghostwriting is. And this also is important. We're talking about artificial intelligence and the ability for AI to be able to detect malware. So if I look at a function, okay, so this is a lab that, or not a lab, this is just me using ChatGPT to kind of articulate kind of how malware would be detected inside of like an AI neural network model, trying to identify not just malware, but also vulnerabilities. So here we've got this assembly, right? Oops, let's go back over here. All right, so I'm going to go back to view. Let's go back to full screen. Here we go. All right, so if we have a function, let's say gets, right? Gets as a function, or some people call it getS, right? It stands for get string. It is inherently vulnerable, right? And it says, what does this look like in assembly? So what happens is ChatGPT says, here's an example of this being coded in assembly, or sorry, in C. And then this is the actual assembly for it. Okay. So assembly is one step above those ones and zeros that you have. One baby step above those ones and zeros. So we have this, and this is what it looks like in assembly. And the key part is right here. So we can see that we have the registers being used. So we got the pointer, we got the function, we have this string right here. Okay. And in assembly, when you're using AI or you're using an AI-based AV, it can go through code and it can look through and look at example malicious functions by looking at the assembly, right? So I think I had something right here. The other thing that we have is anytime you have any functions that exist, you have something called a function prologue or a procedure preamble, right? So when you're looking at it, it's setting up a function, all right, where we push EBP, we move ESP into EBP, and then we allocate the size for the locals, and we pop out a value and we return, okay? So we have the procedure preamble, and then we have the prologue. When AI and AV is looking to try to identify malicious functions, it's going through and it's identifying what are the procedure preambles and what are the kind of the epilogues to bind the functions that exist inside of an executable. Are you guys with me so far on that? Does that make sense? So I can also say, let's see if it'll answer this question. I don't know if it's going to answer this. All right, it did. Awesome. Okay, so your AV is going through all of this, right? And it says, here is suspicious memory execution pattern right here in the assembly. And it explains why it's suspicious. Now, what if we could do things to that assembly to scramble it? Okay. So when you're looking all of this, when you're looking at what's going on, your AI is looking for functions like this. Your AI in AV is looking for functions like this. Your vulnerability management tools are looking for functions like this getS function as well. So it's scanning through the executable and it's trying to find these functions. What if we could scramble it? What if we as attackers could scramble these functions in such a way? And it turns out you can. And I'm going to give you one example of ghostwriting, because when you're looking at, let's just say assembly, and you're looking at this code, there are multiple ways to do the exact same thing. Let me give you an example. I can do 2 + 2 and I get 4. How can I use 2 2s, get a 4 without adding? Does anyone know? How can I use 2 2s? I can't add them, but I want to get a 4. 2 times 2? Could. That'd be a thing. What is another way? What if I tried something like 2 minus a -2? 2 minus -2 is actually really different when you're looking at the way the numbers are stored in binary. But it's still going to show up as a 4, right? So there's this magic that you can do at a much lower level where you can mess with the assembly to mess with AI and antivirus's ability to be able to look for potentially malicious patterns. All right. So let me give you an example. And this is just an example setup. I'm trying to create malware. I'm loading in the libraries and ASM for doing disassembly of executables inside of Metasploit, creating a raw payload. You're going to do this in a little bit. You're going to create payloads. But this is what the assembly looks like. Right? When I create that malware utilizing the Metasploit, I have a whole bunch of assembly code. And I know that AI and antivirus is going to go looking for potentially malicious functions. I'm going to be honest with you. I don't even know what the hell this is, right? Like going through and looking at this ASM, I've got an idea, allocating executable. We're going through in racks. We're putting it into an allocated region. Oh, it's almost like memory that's read, write, and execute. Put that feather in your cap. We're coming back to it later on. But the point is, your AV is going to look for these potentially malicious functions. How can I mess with that assembly? And here's the trick without even knowing assembly. So this is a great trick to do at holidays with your family, your friends, and your pets. Thanksgiving, Christmas. You just whip this out and you're like, hey, everybody, stand back. I'm going to modify some assembly. So you take this code and you look for functions that you know you can modify. Here's an example. You have this XOR EDX to EDX, you have XOR EDI to EDI, XOR EAX to EAX. Now, some of you may not even know what that is, like what is XORing and how does that actually work. So what I'm going to do is I'm going to teach you all how to XOR, and we're going to do it here in the next... Oh, geez, I don't know. How about I set a timer, 2 minutes? All right, 2 minutes. I'm going to teach everyone in the room how to do XORing. So I'm going to have 2 strings in binary, right? Now, the rule is very, very, very simple. If the top and the bottom binary value equal each other, like this 1 and this 1, they're the same. It gets a 0 value. If they're different, it gets a 1 value. This is the same, this is the same, that's different, and that's different. Now, that's all XOR is doing. Is it's comparing 2 strings, and where the bits in the string match, it's a 0. And if they're different, it's a 1. That's all XOR is. Now, why would we do this? And we're well under 2 minutes. Why would we do this? Why would you do this in computer science? Well, I want you to think of a password, right? When you think of a password, your password isn't like supercalifragilistic or supercalifragilisticexpialidocious. It's going to be converted into a series of 1s and 0s, right? Like your password is going to be this long string of 1s and 0s. And your computer has no idea the context of these 1s and 0s. It's a stupid machine. It's just moving 1s and 0s and bits across. But I want there to be a program to compare those 1s and 0s to each other. I can do exclusive ORing, where I can take the real password, load it into memory, and do an exclusive OR with the password that I typed in. And if the passwords match, all of these will equal 0. If the passwords don't match, I will get something that's not 0. So you can use it to do comparisons. Does that make sense to everybody? All right, so let's go back to the slides. Now, if you look at what I'm doing to a register is just an area of memory that your computer can access with little to no penalty. It's really fast area of memory. And registers are like little itty bitty buckets where you drop like 32 or 64-bit data into these little itty bitty buckets, and then it processes the data in those buckets. That's all a register is. Now, if we're looking at these itty bitty buckets, I have a bucket named EDX. You can put anything you want into it, right? And I'm doing an XOR from EDX to EDX. So if I take a register and I XOR it with itself, what is it always going to be? It's always going to be 0. If I take a register and I take what's in that register and I compare it with what's in that register, it's always going to be 0. What this means is that it'll always be zeroed out. What this means for me as an attacker is I can do anything I want to that register right before I XOR it. So I can add one, I can subtract one, I can do all kinds of different things to it because I know that at the end, it's going to be zeroed out. So you can go into assembly and doing examples like this, or the stupid little subtract a negative value from something instead of an add. You can do that through the entire executable. And all of a sudden, when your AI, like antivirus, is trying to find a really simple, clean memory execution, it's not going to find it, because you have rewritten the assembly in a multitude of different ways that doesn't match what the AI is looking for. Because AI is not what you're looking for. How far down the rabbit hole can you go? So there's this coding language out there. The most difficult coding language in the world is a coding language called Moblong. Okay? Go here. Let me show you. Let me go back. So Moblong was created as a joke. Okay. But it is a Turing complete coding language. And if you were going to write the program Hello World, this is how you would code it in Moblong. Isn't that wild? You can have a whole program that reads a string from user input and outputs it, and that's what that program looks like in Moblong. How was AI trained? Everybody, how was AI trained? Anybody know? We got AI today. How did we get it? It was trained badly, but on what data? AI was trained on human data. It was trained on human code. So everything it learns, what is normal, that is what abnormal, all of those different things was trained on our code. Now, yes, it can learn Moblong, it can learn all these different things. But the point is, when you're dealing with high volume systems that are analyzing large code sets and large code bases, looking for potential exploit or potential vulnerability activities, it has to move fast. And we can mess with the assembly in such a way that it is going to lose its context cues, right? You can finalize the payload, run the multi-handler, and run with it. We can also use LOL bins, living off the land binaries. This is where we use the binaries that exist on a computer system to to execute malicious files on the system. So one of the ones that we use all the time is run DLL32. You can run DLL32, pull down an ActiveX control from the internet, do WinSH and execute scripts on the system, and you're utilizing the built-in libraries on a Windows computer system to execute your malware. But there's a problem here. The problem is that initial code execution. If I can get that foothold, it opens up the possibility of me using living off the land binaries and a whole bunch of other different techniques to move laterally on that system. I want to close that door. I don't want the attacker to execute initial code execution in the downloads folder, in the desktop folder, in temporary internet files. And that's what we're going to be shutting down. So the point in all of this is that what worked in the last few slides might not work tomorrow. AV dodging is very much a dynamic, artistic process in what you do. I have 5 people dedicated to this task at Black Hills Information Security. You have to go through and start being flexible and creative on all of these things and what we're doing, and test and retest on it as well. Now, there's a bunch of different ways we can do what I just talked about. We can do Shikata Ganai, which is another type of encoder. And the reason why we would use something like Shikata Ganai from Metasploit is there's certain strings that are bad, okay? AFFF00 are often used as terminator strings in hex. We don't want to use those in our malware or our exploit. So you can do that type of encoding and re-encoding to avoid those specific bad character sets. There's also tools like Unicorn that make this process a lot easier to do for anybody that is out there. So if you want to learn how to do it, you want to have a tool that does it, you can use it. So let me show you something that we're working on that I think you're going to like. So I'm going to go to backdoorsandbreaches.com, and I want you to go to backdoorsandbreaches.com as well. And I want you to register when you have time, but go ahead and get registered. And we're going to go into the cards, and we're going to go to core deck. All right. So whenever I go into cards and core deck, almost every single thing we talk about in this class is represented by a backdoors and breaches card. It is. So if I want to look at, let's say, endpoint security protection analysis right here, I can select that card and I can flip it over. On the other side of the card, there are a bunch of defensive tools and then what this particular defensive strategy detects. But down at the bottom, we have labs. We have all kinds of labs to learn how to do this thing, right? From App Locker, Atomic Red Team and Blue Spawn, Caldera, Elastic, things like that. Let's see if I can find it. I thought I had a lab for Unicorn in here. But we have all of these different labs that exist for you to learn how to do these things. So if we're looking at like persistence mechanisms, we're talking about, application shimming, malicious firmware, malicious service, all these different things. If you want to start learning more tools and different ways to detect these different things that show up, you can go to these cards, flip them over, and we have a whole bunch of different labs associated with that specific technique or that specific technology for you to learn how to do these things as well. So a bunch of really, really cool ones and tools to learn and all that stuff. So this is an opportunity for you to take what we learn in this class and extend it dramatically in everything that you do. All right. So lots of tools, lots of cool stuff. Also, if you want, you can also play competitively against each other. So if you register, I'm John and John too, and you can play a competitive game in the browser, and I'll show you how to do this a little bit later. But if you guys could do me a favor, if you could go in and register for backdoors and breaches and create an account and get logged in, maybe I'll play a game with you guys when we do the Ask Me Anything with that as well. All right. So that's Unicorn. Now let's talk about application allow listing techniques and what we can do to try to shut those attack methodologies down, or at least limit those attack methodologies as much as we possibly can on that as well. So here we have, these are common places where malware executes: the downloads directory, the desktop directory, and the temporary internet folders for browsers. So we need to go through, we need to stop that level of execution. So you can go into your application allow listing methodology, and you could try to allow list every single executable. That's really hard and it's not advisable. The only way that this would be advisable is if you were working on a kiosk system and you were restricting it for like a bank teller, right? Or somebody that's a point of sale terminal where you want to weld everything shut on that computer. That would be it. Possibly Citrix or, VDI environments where people are running virtual desktops and they want to get the exact same desktop with the exact same tools every single time. That may work, but honestly, I don't recommend doing this for general purpose computing. You can go a little bit further and you can do digital certificate and publisher verification, where it goes through and you can, like, all the executables on your system that are coming from legit vendors will have a digital code signing certificate, publisher information, and you can restrict that executable to just that publisher. And I'll show you how to do this a little bit later as well. Now, the tool that allows us to do this is a tool called App Locker. App Locker allows us to do application allow listing that can do it based on path, hash, cert, or vendor. And I'll show you what this looks like after we get done with the lab here a little bit later. Now, we go into the local security policy. We set up the application control policies for this system. And we'll show you how to do that, and creating the rule enforcement on the system. And we create the default rules. The reason why we're using the default rules is it restricts execution based on the directory that it executes from, based on the directory of execution. Now, this can be bypassed. I want to make it very clear, especially with the living off the land binaries. But what we're trying to do is we're trying to shut down that initial code execution on the system. Trying to stop that attackers from getting that initial code execution. And once again, the front door is usually through temporary internet folders, downloads, the desktop. The user will download a file, execute it, the malware will detonate, and things like that. So the default rules say everything in the program files can run, everything in the Windows directory can run, and the administrator accounts can run anything they want. That's your recovery. That's your lifeline in case something bad happens on this computer system and you need to be able to recover and do something on that system. Okay. Final steps, you got to enable the application identity service, and then you have to set GP update, and you have to force it. All right, so let's go ahead and let's get set up in the cloud environment. So if I'm going to go through the instructions here, let me go into Discord, and we're going to pull down resources on how to get set up in this environment. I'm going to copy this link. Okay. And I'm going to go over here and we're going to go into Google Docs. So in here, I know that this is active defense and cyber deception, but it's the same lab environment, right? So it's going to say register, create an account, right? Or you can go in with your existing account and you're going to go into the Cloud Labs section. So I select Cloud Labs, and then here it's asking for a code, right? The code that we're using for this class is DEC E4XWK7. I just take that code, copy it, and then I paste it in here, and then I hit submit. Now I'm going to get an error. I've already claimed it. As soon as you do that, you should see this right down here where it says active defense and cyber deception with John Strand. Okay. Now, once I'm in there, I can click view and manage lab. And I have two separate VMs that are available to me. I have my Kali VM, which is a Kali VM, and then I have a Windows VM, which is a Windows VM. All right. For these labs to work, you need both of these to be running. And to do that, you select Start All Machines. And if I do this, get the request, I've already started it. I select Start All Machines, and it's going to take about 2.5 minutes for the powers of Amazon to be able to fire up these virtual machines. All right, it's going to take about 2.5 minutes. Then once it's running, you're going to hit connect via RDP. But before I do that, I want you to know that we've given you 16 hours of lab time as part of this class. It's just part of the course, right? You are burning credits as soon as you fire up these virtual machines. In your upper right-hand screen, you can see your balance. I have 78 or 68 credits, right? So I got a lot of credits there. So you can see your credits and you're burning them. If you're not actively using your lab environment, I strongly encourage you to destroy the lab. It kills the lab, stops burning credits, and it resets the lab back to a pristine state when you hit Start All Machines. If you're in the middle of something, like you got breakfast or lunch or something like that, you can do Stop All Machines, and that pauses them. So if you're at the end or in between labs, destroy. It's much easier and it's cleaner just to destroy and start clean. But if you have to run away and do something real quick, do Stop All Machines, and then when you start it, it'll restart to where you were. Okay, so it's like virtualization in the cloud. Now, once you're in, you do connect via browser, via RDP. We use Guacamole for this, and it's all going to be browser based. Okay, it's all going to be browser based. Here we go. And then we're going to get to the labs. I think a number of people have been sharing the lab that we're going to be doing here. I think Jesse got it, so I'm going to copy that text. All right. So now I have my lab up and running, and I know it's working because I can interact with it. I can click on my Kali terminal, and it pops up this. Just click accept, and it's going to log you into your Kali system. I'm going to change my settings. We're going to do appearance. We're going to change the font here in a couple of seconds, just getting set up. But while I'm doing that, I can show you the labs that exist. We are doing the App Locker lab. Thanks again to Jesse for that as well. And yes, as Brian just mentioned, if you run out of credits, you can totally just go in and buy more. They're really inexpensive for lab environment time. So we have step-by-step instructions on how to do this lab. We have step-by-step instructions on how to do it. So I'm now in, I'm going to make my font bigger, going to do this. So you're going to do this lab on your own, but then I'm going to come back and I'm going to do it slower. Okay. The first thing that we do in the lab is we disable AV. Once again, the goal of this lab is not to show you, here's how we bypass AV. The goal of this lab is to show you how we can restrict execution on the system by using App Locker. And then the lab goes through step-by-step instructions on how to infect your Windows computer system with malware. Right. So we're going to go through all the steps utilizing Metasploit, creating malware, moving that malware over to the system, executing the malware on that computer system. And then we're going to show you how to stop it from happening. Right. Because this malware executes from like the root of C on this system. Then you're going to go to a local security policy. You're going to go to App Locker. You're going to create the default rules. Do not do automatically generate rules. Once again, pretty please, do not do automatically generate rules. We want to do create the default rules, and that's going to create 3 rules. It's going to be the programs are allowed to execute in program files. It's allowed to execute in the Windows directory. If it's not listed there, you can't run malware there, right? So then you're going to configure the rule enforcement. Then you're going to go into services. You're going to start the application identity service. So click start. And then you're going to do GP update force. This may take a couple of seconds for it to take effect. Then you're going to CD into intro labs, and then you're going to try to run a random executable. In this situation, the netcat executable. And you're going to get an error. It's going to say this is blocked by group policy. All right. So there you go. That is the lab. Now this lab is going to take us up to and through the break. But before we do that, I want to go back to backdoors and breaches. As I mentioned, a lot of these cards have labs on the back of them. So if you get bored and you're like, well, I want to play around with memory analysis and I've got more labs, we have a ton of labs in this class. If you want to see the labs for this class and other classes, you can go to the lab list. That's one way. But the other thing that you can do is you can actually go to the labs for these cards, and there is a lot of new labs that we've created. There's over 200 that we've created as well. Let me share that link with you. Oh, that one didn't get updated. But I can get that link to you all. But we have over 200 labs associated with these cards. Just a tremendous amount of labs that we've generated for them. Let's go to this one. Oh, it's coming back to the same one. Oh, we do have more labs. Okay, so here's a bunch of labs, right? So we have a bunch of labs, but we also have labs based on the cards themselves. So I'm going to share all this with you guys, but the code for that lab environment, don't use it for this class yet, is just anti-labs, anti-lab, like that. Anti-lab, you put that in the code, it opens up the new VM for that as well. And by the way, we're going to be doing something where in the future, we're going to be doing free lab Fridays where we're going through a lab, we're doing a walkthrough, and everyone will get 2 free hours of lab time per week to be able to do that. So a lot of really cool stuff coming down the line for you all to play with. But are you guys getting registered? Like how many of you, can I get thumbs up? How many of you have actually gotten registered for playing competitive? Got some open games. So this one I can join as a spectator. So we have two of you playing right now. We have Nomnol and Adrian are playing each other right now, and we can watch their game. And I'll go through and play a game during the Ask Me anything phase. But I would like to play against one of you. So maybe we'll play with 4 people, and we can do it that way. I'm actually halfway thinking of creating a class where we just play the game, and we just set it up that way as well. We just do the labs that way. All right, so that's it. So let's go ahead and let's get rolling. If you guys need anything, please let us know. We're going to resume at, let's go ahead and resume at 40 after. So we have a good chance for the break. So we got a 45-minute with break and lab time. So go ahead and hit start on that. So we've got a 45-minute timer on the break, and we will resume. See you all in a bit. Ooh, wow. That stalled a little bit. Click the unmute and take off the AV mute, and it's like hung. And I'm like, oh God, is Zoom crashing? Oh my God, it's happening. It's happening. All right, so let's go through this lab real quick. What lab are we doing? We're doing the app blocker lab today. All right, here we go. All right, so the first thing that we do is to disable the antivirus on our system, which once again, the goal of this lab is not to bypass AV. It's to show you how we can restrict malware from executing on the system. I'm disabling the firewall and I'm setting the password to be something super easy for me to get down to the point where I can get that malware on the box and kind of show you how it works. I'm going to get the IP address of the system like so. And I'm going to slide that right on over here because I'm going to need it here in just a couple of seconds with the malware that we're going to be creating here in just a couple of moments on that. So I'm going to become root like so. And then we're going to mount a share on the remote Windows computer system. So I'm going to put in my Windows IP address here. Here we go, 10.10.64. Oh, it's 10.10.107.229. Make sure I got that right. 10.10.107.229. Mount the C drive. We're in. And then I'm going to CD to that share, mounting that share over like that. Now I've logged a share on that system. So I'm effectively on the hard drive of the Windows system. I'm going to get my Linux IP address really quickly. And then we're going to generate our malware, right? So this is what I was talking about, that malware generation. And I need to put in my Linux IP address here. So put that in as 10.10.94.127. And we're going to create some malware. And the name of the malware is Trust Me, because it's important anytime that you're creating any level of malware that you give it a name that instills trust, like Trust Me. Because then if somebody sees this, like this is totally a trustworthy piece of malware. I kind of akin this to the Saturday Night Live sketch, Land Shark, where it's like, Land Shark, I'm not letting you in. Candygram, they're like, yay. Coming up with the right name is a super important part of creating super cool malware. Now I'm going to run MSF console to get our Metasploit environment built, which once again takes a while to run. And the reason why is because Metasploit is the world's largest Ruby environment. Also, we're running it on a very small CPU memory disk system in the cloud. We do that to keep our costs low and pass the savings on to you. But we're generating the malware, but then also when we start Metasploit, it takes a while for it to get all of those different various libraries up and running. I did the Q, in case you're wondering. Q stands for quiet, because I am sleeping. So the Q means just don't give us a bunch of banners and things like that. And if you want to know what the banners are, because I got people like, well, I want to see the banners. If you type banner, it shows you the banners. There's lots of banners for Metasploit that people can use, and some of them are pretty cute. Some of this is one I don't do. I have people that are like, I got an error. It said that my password was incorrect, or this one, kernel panic. I tried to run Metasploit and there was a kernel panic. It's not kernel panic, it's a banner. I get rid of all those problems with my classes by adding the Q to it. So we're going to start by using exploit multi-handler. The multi-handler is just a generic kind of exploit class that works on multiple operating systems, hence multi. And the handler means it's handling reverse connections. So multiple operating systems, handler for reverse connections coming in. We're going to set the payload to Meterpreter reverse TCP, which, by the way, is the same payload that we created our malware with up above. Right? So we want to make sure those two things match. I'm going to set the L host to be my Linux IP address, which is just ETH0 on this system. And I'm going to type exploit and nothing's going to happen. It's just going to say handler started on 0.0.0 on port 4444. And that means we're just listening. Now I'm going to open up a command prompt on my Windows computer system right here, like so. And we're going to run trust me on the system. Now I could run trust me just about anywhere, right? I could run it at the C drive. I could run it in downloads. I could run it on desktop, internet files, all these different places. And trust me would execute. And an attacker's not always going to work the way that I just showed you, right? They're not going to mount a share and upload malware. They might put it in a Word document, right? They might put it in an ISO. They might put it inside of an Excel spreadsheet. There's a number of ways that you can get malware to a system. But usually that initial code execution for exploitation will be in a directory that is commonly used by the user. That could be the desktop, that could be the downloads folder, it could be a number of those different things, right? So this happens, right? I got a full interpreter session. I have all this stuff. I can dump hashes off the system. I got full access, right? So malware is the order of the day. Now, how do you stop that? How do you try to shut down like 98% of those initial code execution examples? So if we want to do that, we're going to go into the local security policy. I'm just going to follow the instructions here. And we're going to go into application control policies, app locker, and we're going to create the default rules. That's going to create the directories that programs are allowed to execute in. Then I have to configure rule enforcement. These are all configured and enforced. I can close that out. And then I'm going to start services. And I'm going to go to the application identity service. We're going to start that up. There we go. Now I have one more command to make sure it all hangs together like a nice rug, man. So now I got to do GP update force. My command prompt. And that's going to force that policy on this system, right? It's going to force that policy onto the system. And then I'm going to CD into intro labs. And we are going to try to run netcat utilizing the user whitelist. Like so. ADHD, and I get an error, unable to run this program. This program is blocked by group policy. For more information, contact your system's administrator. All right. So what would happen is now if somebody sent something to this computer and they tried to run it from the desktop or they tried to run it from downloads or anything like that, it's not going to work because it's not in a directory where programs are allowed to execute. And the power associated with this is, in fact, substantial. The reason why it's substantial is because a lot of the initial execution vectors come through those types of directories. But we can go deeper, right? So I can go into App Locker and go to execution rules, and I can generate more rules for more flexibility. I can go create new rule. I can say anyone is allowed to execute a program based on publisher. Right? If I choose that, I browse and find a file, let's say putty. I want everyone to be able to run putty. And I can put in a rule that anytime anyone ever tries to run anything from Simon Thatham from Cambridge, Great Britain, running putty file version, I want to pull this back so any version of putty is allowed to run. I can now create that rule as an exception. And now putty runs everywhere. Right? It's now a trusted binary. This is important because you may have some programs that get downloaded from the internet and they have to run from temporary internet folders and other places like that as well. The other thing that you can do, let me show you, I can go automatically generate rules. Now, once again, this is something that you would only do for a kiosk system that is very strict down to its purpose. If I do this, it goes through all of the programs in the program files directory, generates full hashes for every single one of those program files so that only those programs are allowed to execute on this system. This is very, very thorough, but there's a couple of problems. Patches and updates may create massive issues for you. If you have a user that needs general purpose computing where they're downloading things, or maybe they need stuff that's a little bit more dynamic than a lockdown kiosk, it might break. But once again, it's about establishing the proper use case for the proper threat model that you're dealing with. So if I create these rules, it has now created a full set of rules for every program in the program files directory. All right, so I've severely messed up my VM. You have too. So I'm going to close it out. And I'm going to destroy the lab environment. We're just going to nuke it from high orbit because it's the only way to be sure. So we destroy lab, we've completely blown it away. And then in a couple of seconds, after it's done destroying, we're going to do start lab, and then we got a pristine copy to work with on it as well. So still destroying. All right, so let's get into some password controls and get into another lab for you all. So we've got a problem here. We got a big problem, as a matter of fact, in password spraying, right? If we're looking at password spraying, the idea of a password spray is that somebody can remotely launch an attack against your computer system, and it's very difficult to detect. And the reason why it's difficult to detect is because of the belief and over-reliance of things like account lockout. Account lockout is so many failed login attempts will lock an account. So if somebody tries to log into my account, let's say over 10 times, it's just going to lock my account out, right? And that's a good security thing. Maybe not externally, but it's a good security thing. However, if we are dealing with an attacker that is smart, they aren't going to password spray against one user account. They're going to password spray against all the user accounts. So they gain access to a system, they gain access to some recon, they gain access to a user list, which they can do external recon and all of that. And then they start spraying every single one of those users with the same password. Something like season and year requires the attacker to do some user harvesting, and it feeds those IDs directly into their tool to attempt that password against multiple systems. So the time to compromise associated with this particular technique truly depends on the size of the network. Believe it or not, larger networks are more insecure than smaller networks. That's because the overall attack surface and the likelihood of being able to come up with a password that somebody was going to use, like season and year, company name 123. If you're going against a company in, like, let's say Denver, you could do Broncos, whatever the year is, whatever the sports team is in your area. You're going to get to a point at about 10,000 users where there's a high probability that somebody in that organization is using one of or a variation of those passwords out there as well. Chad just said, Red Siege class. They asked how many orgs use like winter 2026 and get you in. They said about 80%. Now, let's put in some qualifiers around that, right? Number one, two-factor authentication, which we're going to talk about here in just a few moments, will reduce that risk, but not to zero. In many organizations, they have exposed APIs where two-factor is not enabled. You'll have a number of different apps where maybe conditional access policies, things of that nature, where two-factor is disabled. So a really good attacker will try to identify all of those different APIs, those different services, interrogate those services, and then attempt password spraying on those services where two-factor is not enabled on those systems. And this is an example of what password spraying looks like, right? We can put in, a company name, and then it's going to go through and it's going to identify all of the different user IDs in that space. Now, the reason why a lot of this actually works is the lack of two-factor authentication. Just going to be honest with you, it's a problem, right? That's what I'm trying to get to, is it's absolutely a problem. And if we're looking at short passwords, we still have large sections of the industry that had really small password complexity requirements. And a lot of that actually goes back to the NIST Green Book. So if we were to do a search for, let's say, classic, let's go 1985, right here. They remove it? Oh, they removed it. Oh my gosh, it's got to be out there somewhere. They can't hide from me. I think this might be it. There we go. So this is the green book. So you have this section in this that basically says L is set for 6 and 12 months. B is set for 1 in 1 million acceptable probability of guessing a password. R is set at 8.5 guesses per minute. The guess rate possible with an 300 bot service. At 8.5 guesses per minute, the number of guesses per day would be 12,240. Substituting 138 days or 183 days, they get an equation, they get some math, and they come up with this table. They say, what is the maximum lifetime in months for a password? If you were applying the same logic in 1985 to today's passwords, you would have to change your password once every second. That's how crazy this policy is. But the problem is, up until recently, a lot of password policies were still stuck in NIST Green Book. So if I go, what was the old policy for, let's say, PCI. Up until about 2 years ago, the password for PCI was 7 characters long. That's like they looked at the standard from 1985 and they're like, no, that's too much. We got to roll that back a little bit. So that's scary, right? But once again, one of the things we see with organizations still today is, let's say that they're in an old password regime and they're like, yeah, well, we have the old passwords of 8 characters or 7 characters. Even today, organizations say we have systems that do not support longer passwords, and we're going to need an exception because of our legacy systems. And they're right, they do. It's not a matter of them being lazy. There are operating systems that cannot handle passwords longer than like 9 characters. Old Solaris Spark systems, RACF systems, they just can't. And these systems are running the heart of their entire enterprise. So we continue to see these problems again and again and again as well. Now, once again, that short password problem, that only works if you have, or with two-factor authentication, that only works if all of your passwords are using two-factor authentication. The problem with that is a lot of organizations have hidden APIs and they do not support two-factor authentication. So we're going to do a lab real quick to show you what an external password spray looks like. I'm going to take this, copy it, and paste it into the lab so we can kind of establish that problem statement. We have the MITRE attack technique associated with it, the threat actors that have been using it. And we're going to do very similar to what we just did in the previous lab. We're going to go through and we're going to generate 200 users on this system. Then we're going to open up Kali, become root. We're going to generate a user list. I just pretend the attacker did recon. And then you're going to use Metasploit to do a password spray remotely against your Windows computer system, right? We're going to clear the event log so you can see what the event logs look like on a password spray attack as well. All right. And then afterwards, I'll show you how we can log in. Does that sound like fun? Let's do some lab off-roading. My day can't get any more interesting. So this lab is going to take us, let's do 40 minutes. So we can set the timer. Actually, set it for 42. We'll give them a bonus there, Daryl. So we're going to do 42 minutes with the lab and the break so you can get used to password spraying. All right, I'll see you on the other side. Such good timing bringing us out. It's crazy. All right. So in this lab, which I didn't get started in time, we're really focusing on one of the primary techniques that almost any offensive oriented company is going to use, right? They're going to use an external password spray. God, I just got the hiccups really bad. That they're going to use that external password spray against a target organization. It just works, right? What's interesting about this password spray technique, the T1110, is that I actually had to lobby MITRE to get it added. It wasn't in the MITRE attack technique matrix a long time ago when they first started, and we kind of got into a little slight tiff about it. Despite what happens publicly. I try not to get into public fights at all. But I got into a little bit of a fight, not publicly. And I said, this is a technique that we use all the time. And they said, well, we use techniques that attackers use. We don't use techniques in MITRE that pen testing teams use. And I got to say that hurt a little. So we went through a lot of our IR engagements and we started finding a bunch of situations where, sure enough, there were nation state level adversaries that were actively utilizing this password spraying technique to gain access. One of the first ones that we were able to talk about publicly was the FBI. FBI holds my clearances still. And we had found this technique worked on them and we were able to coordinate with them to get it removed. And then they saw it being used on universities and they saw it being used in a bunch of other institutions, right? And it is now, it's one of the go-to methodologies that in trying to create a malicious app or using something like EvilJinx to generate phishing, which by the way, if you want to generate phishing and you want to learn phishing, you can go here to the cards, you can go into core deck and you can go to the phishing deck right here. The phishing deck right here. And we have a whole bunch of labs that'll show you how to do phishing right here. We have Canary tokens, EvilJinx, GoFish, another one for GoFish, Maloney, Modalishka, and Social Engineering Toolkit. So sure enough, we have labs for a lot of those. Maybe not all of them. There we go. So we've got a bunch of cool labs to play with to learn phishing, right? So you have all of this, right? That's available to you to continue learning, but it is just a technique that we use all the time. So one of the questions was, is this a goated technique? Yeah, this is one of the goated techniques. All right, so let's connect in and let's actually get started running through this lab. Once again, the first thing I'm going to do is disable AV, which I don't think it's necessarily 100% needed for this particular lab, but you just get into the habit anyway. I guess makes problems go away. Kind of house cleaning, I suppose. Then we're going to get our IP address. We will be needing that. Absolutely, because that's going to be the system we target. I'm going to go ahead and open up a Kali terminal over here. Let's go ahead and set my IP address right there. There we go. And let's go ahead and change our settings, appearance, change our font, let that percolate for a second. I also want to set the firewall off on this system. And then I want to go to the intro labs directory, like so. And then we're going to pull down the 200 user gen batch script to generate the 200 users. There we are. And then we're going to go ahead and run it. Oh, I know what the problem is. Never mind the man behind the curtain. Oops. It was in the wrong terminal. See, even I make those mistakes too. That's fine. There we go. And let's go ahead and run that script. Run that script. So now we're generating 200 users. We've got our Kali system over here, setting that font to bold. There we go. That's running. I've got the IP address there, which is 10.10.124.134, which is good. And then we're going to get started on the attack. So we're going to become root first because we're going to be using Metasploit again in this situation. And then I'm going to download a user list. Now, this is, imagine the attacker did a bunch of recon. They have a user list that they can work with. That's what we're emulating here. So once I've gotten a bunch of users, I can run MSF console, run that in quiet mode once again. And we're going to use a completely different situation. We aren't even using an exploit at this point, which I know seems kind of weird. Yeah, we're not using an exploit. What we're actually doing here is we're running something called the SMB scanner. It's running SMB login. It's a scanner that searches for server message block or Windows servers, and it's going to log in to the system. So let's go ahead and let's copy that. Because we're waiting for Metasploit to start, so it should be just a couple of seconds here. By the way, copy and paste, I use Chrome, and it works really, really, really well. The other thing that you can do if you're having trouble getting copy and paste working is don't keep your lab in a separate tab. That kind of rhymes. I think that's kind of funny. But you can do your labs directly in the browser itself. So you can go right to the labs right here and go to interclass files. I think I went too far. But you can go right to the labs directly in, oh, here we go, navigation. You can go directly to the labs within the VM, and then you can copy and paste directly in the VM. Just treat it as its own little computer, which is what it is. So we've got SMB login. There we go. We're going to use that one. Then we're going to set the R host to be our Windows IP address because that is the system we're attacking. Mine is 10.10.124.137. Like that. Now we're going to set the user file to be users.txt. That's the one that we just downloaded from the interwebs that we would have. We're going to set the SMB pass to be winter 2025. Like that. And we're going to clear the event logs on the Windows system just so we can get the clean and pristine event logs. Go Windows, Security, right-click, clear the logs. It's going to ask me a quick question here about that. I'm going to say, well, yes. Yes, I would like to clear the event logs. Just clear them. I don't need to save and clear. All right, there we go. And then we're ready to go back to Metasploit and do a run of our attack. Let's kick off our attack run. So we see all of the failed user authentication attempts coming up. Eventually, you're going to see some green pop up here. And anytime you see green, you now know that you have access to that. So let me go ahead, close that. Oops. And then we have an administrator account right here. Dennis has a winter 2025 account. So now I can do use exploit Windows. Let's do SMB PS exec. Like that. Set the payload to be Windows. Tab autocomplete. Meterpreter. Reverse TCP. Set the SMB user to be Dennis. Set the SMB pass to be winter 2025. Set the R host to be, what was it? I think mine was 10.10.124.137, and then exploit. Now it's going to attempt to authenticate to the remote Windows system. There we go. And now we can leverage that password sprayed credential to gain access to the system as well. So there you go. That's me going off-roading. All right, so let's go ahead and let's kind of keep going. So hidden two-factor bypass. As I mentioned earlier, it's very, very common for people to have multiple different apps and APIs that exist in an organization, right? It is very, very common, right? And all we have to do is find some app, some API that has simple user ID and password with no multi-factor authentication. And this, you can find these in your organization by looking at things like conditional access policies and trying to pull them down. So when we're also then backing up, if we have a situation where we don't have two-factor authentication, where are we at? We're really at a situation where the only thing that matters in your passwords is length. That's it. Every time, I know this sounds weird, but trust me, every time you add one character to your password complexity requirement for length, it more than doubles, just slightly more than doubles, your total key space. Let me explain why. If I have a 5-character password requirement, then all I have to do as an attacker is crack 5 characters. If I have a 6-character requirement, I have to crack all the 5-character requirements and all of the 6-character requirements, which will inherently incorporate some of the 5-character requirements as well. So for each character that you add, it doubles, a little bit more than doubles the total amount of passwords that you have to crack on these things. So two-factor, as many of you are aware, is something you know, something you have, token-based, SMS-based. A lot of people shit on SMS and they're just like, well, it's bad, the attackers could just clone your SIM. That's 100% true. It is. But the reality is kind of boiling down to, well, what is your threat model, right? If your threat model is like Black Hills Information Security, where we have nation state level adversaries coming at us, then yeah, that would be a problem. You would worry about that. If you're just a construction worker or a nurse or an accountant or a lawyer or any of those different things, odds of somebody actually going through the effort to try to do SIM cloning against you are pretty low. I'm not saying it's zero, but it's pretty low, just because it's a lot of work for very limited return on investment in it as well. The other thing that we look at is service accounts. Now, some people had mentioned Red Siege. Red Siege is a great company, and the founder of the company, Tim Medine, found the attack technique called curb roasting, where you can actually go after service accounts, and any user in an environment using curb roasting can pull down the password hash for any service account. And a lot of those service accounts are pretty highly privileged accounts in an environment. And a lot of service accounts are set up where they don't have account lockout, never ending passwords, and they're often overlooked by security teams and beloved by hackers everywhere. If you're doing curb roasting, there's a number of tools out there. I just talked about that. There's a great presentation on curb roasting that Red Siege did a little while ago. We also have other protocols where we can intercept password hashes. We can attack link local multicast name resolution, MDNS, NetBIOS name services, WPAD. A bunch of these different services can be utilized relatively easily to basically trick a system into sending you their authentication. You can use these in conjunction with things like ARP cache poisoning. The point is you're creating a system with a bunch of services right here. You can see we have a web server, WPAD server, SMB, Kerberos, SQL, FTP, IMAP, POP, SMTP, and DNS. And we can create poisoners that redirect that traffic, LLMNR, NetBIOS, and DNS and MDNS, to these services. And these services are just like greedily asking the browser or service or SMB to authenticate. And then it intercepts either the clear text authentication or the password hash. And then we can crack that password hash. Other things we can do with password sprays, we can use tools like CredKing. This allows you to use password spraying through AWS Lambda for IP rotation. Bypassing evil jinx, which once again, we have a lab for that, right? So if I go into backdoors and breaches, if I go to phishing, there we go. We have an evil jinx lab right here, where you can learn. Oh, it's not lab, but I clicked on the wrong thing. Let's go down to labs. We don't have one, but we do. Oh no, we do right here. Oh, the link is broken. God, We do have Go Fish, which is another framework that you can use. So there you go. So you do have them to learn that. Sorry about this. We're just getting this Backdoors and Breaches website up and running as well. Password managers are sweet. They're very good. You have to be careful. Some of them have a bit of a sketchy reputation, like LastPass got into a lot of trouble, not just because they got breached, but also because we found out that they were using AES, electronic codebook mode, which, not getting into weird things, let's just say it's bad. Electronic codebook mode takes every block that is outputted and it uses the same key, which means that secrets that you have with the same data will have the same hash values. That's bad. Don't do that. So that allowed people to see like which passwords were being reused and things like LastPass, which was a bit scary. Privileged identity access management allows you to rotate out sensitive like credentials, like local administrator passwords, which you can change with LAPS from Microsoft. But you have this ability to where you have to check these accounts out. Now, the problem is, this is kind of a bit weird. One of the problems I have with products like this is a lot of these products continue to move to more cloud-based services, which I'm not ripping on them for that. I understand the logic behind it. However, you do run into a situation where this becomes a very big single point of failure. I can't remember what department in the United States was breached, but one of these vendors was compromised and the attackers were using it to log into a sensitive government entity. I think it was Department of Treasury was breached. So you see these types of attacks being used, and it's very, very terrifying to deal with. All right, so now we've got yet another lab that's going to take us up to and through the break. So Daryl, if you want to set the timer, we'll have it close out at 30 after the hour, 30 minutes after the hour. So we go to the lab directory, and we are going to do the password cracking lab right here, password cracking. And you're just going to get some quick experience using Hashcat. Once again, we're disabling AV on this. And then after, we will have an AMA as well. And then you can become root, sudo su space minus. And then we're going to delete the pot file. That's just previously cracked passwords. We just want to remove that. Go ahead and start the clock, sir. And then we're going to cd into opt password cracking. And then you're going to run hashcat against MD5 password hashes. And then you're going to run hashcat against SAM password hashes as well. And then we'll be able to see those dumped passwords as well. So fairly quick and easy little lab. Like I said, it's going to take us about 20 minutes where we have 10-minute break to go get something to eat, hit the restroom. And then we're going to close out today with Ask Me Anything. I'll see you then. All right, all right, all right. We are back. Go ahead and do that. Go. All right. So let's go ahead and let's do some password cracking, because if you ain't clacking, you ain't cracking. So we need to go through and kind of do a little bit. We are root already. I'm deleting the pot file. And the pot file is just where Solar Designer put the cracked passwords for historical context as far as what passwords you have cracked. Now, the reason why you have to do this is these tools are smart enough to not re-crack the same password. They are smart enough not to just, if you already cracked it once, don't waste a whole bunch of CPU time and cracking it again. So we cd into the password cracking directory, and then we're going to start out utilizing Hashcat to crack these passwords. Now, Hashcat is really interesting, and believe it or not, this actually applies to artificial intelligence and video games as well. So whenever you're looking at your computer, if we go back in time, let me show you my favorite video game, one of my favorite video games. One of my favorite video games when I was a kid, I just saved up so much like work and effort to get this game, was Mech Warrior, right? Just absolutely loved this game. And everything about it. It was just, I loved battle mechs. I love battle tech. And I remember hearing someone that was like, hey, they got a game where you can actually pilot a battle mech. And I'm like, no effing way. And like, yeah, it's a game. You literally walk around, you can fly around the inner sphere, and you can buy like a Warhammer and you can break into things. And so excited about this game. And it was every bit as awesome as I remembered it. Now, all that being said, like realistically, it was pretty much the exact same map and the same like 4 or 5 battle mechs again and again and again. And the actual graphics of the game, if you look, were severely restricted to less than 50% of your total screen as well. Now, the reasoning for this is your CPU was actually doing the rendering, right? And rendering of stuff with a single CPU was completely dependent on the speed of the CPU and the level of rendering that you could actually do with it. And you move into like MechWarrior 1, and then they came out with MechWarrior 2, also really good game, but the graphics were better. They were pretty good. Right? They were clearly better than MechWarrior 1. It was a lot smoother and everything. But now you get to like MechWarrior 5, right? And this is what the graphics look like. So what the hell happened? Did CPUs get so much better that they could just do that? The answer is actually no, they didn't. I mean, CPUs definitely got better, don't get me wrong. But what happened with the video game space, if you go back all the way to the Voodoo video cards, right? And 3DFX, they realized that instead of building a CPU that kept getting faster and faster and faster and faster, they realized it would be better if you had lots and lots and lots of little tiny CPUs working in parallel. And the reasoning for that is floating point arithmetic. You have math that's being done for polygons. You have math that's being done for lighting. You have math that's being done for ray tracing. You have math that's being done for movement and ragdoll physics and all of this stuff. And it's literally doing the exact same mathematics again and again and again and again. And instead of feeding that through one CPU to calculate it thousands of times, they realized you could have multiple CPUs distributing that work effort across multiple CPUs. And that gave birth to graphical processing units. So if you're looking at like graphical processing units today, they have thousands of little bitty CPUs on their cards that are doing massive parallel processing. And that's how it does video rendering. Turns out that exact same thing that's really good for rendering videos is really good for rendering Bitcoin, cryptocurrency. It's really good for rendering passwords and cracking password hashes, because all of these things involve you doing the exact same function over and over again in massive parallel distributed computing fashion. Now, When we're cracking passwords, we're doing that. We're also doing a lot of those same types of functions in AI. So that's why you're looking at like an A100 chip from card from NVIDIA is thousands of dollars because it's very powerful in the amount of memory that it utilizes and the amount of like raw GPUs that it has built into it. So Hashcat took that whole concept of like floating point arithmetic and distributing it across a model and applied it to password cracking and brought it to GPUs. Now I had to cheat. I had to make Hashcat think that it can run this with using like OpenCL drivers. But at any rate, it works, especially for the demonstration purposes. You weren't using a GPU out there at all. Like in this, there's no GPU, but we're coming up with really easy to guess passwords like peanuts, tiger, swordfish, thrasher, love 123, and cross country. Now these passwords are, I believe we did NT first. Oh, MD5. So MD5 passwords are the types of passwords that are used oftentimes in like different services, like backend databases and web servers. The one that's heavily used on Windows computer systems is the NT password hashes. So with NT password hashes, that's a bit different. An NT password hash is an MD4 hash of the password, believe it or not. So it's just about done. It got freedom and a blank password 8675309 rabbit 1 follow the white rabbit Neo. But it got our NT passwords. Now, if you look up the Hashcat cheat sheet, we have a really good Hashcat cheat sheet that gives you all the different types of options and things that you can do with Hashcat and how to crack those password hashes as well. So that's it. So we made it through the actual section of today, and now we are in the Ask Me Anything section of the day. So please do me a favor, throw out any questions that you all may have. Got a handful of questions coming up. All right, first question. Yeah, do just type your questions in. We got several people typing, Jelly Beanster. All right, here we go. Can we plan to, when can we plan to restock the Rekka hats? You're talking about, oh yeah, the Rekka hats. I think we just got to do another order is all. Got to put in that request. A lot of people typing. I'm afraid, Megan, these look like long.
I know. Well, it's just like the anticipation of it.
Is joining InfoGuard as a student recommended? Yes, it is. Don't just try to join InfoGuard. Also, as a student, offer to share your research at InfoGuard presentations. The reason why this is so important is because, one, all the people that are hiring you are going to be in that room. And number two, InfoGuard is constantly trying to get people with good content because a lot of their content that they get are just presentations by vendors talking about their tools. And people hate vendor presentations like a lot. So it's a great opportunity for you to get out there and present and get a chance to get out there and just really, see, the industry as a whole and get a chance to speak. Never turn down an opportunity to speak. Ever. It's like Toastmasters. If you get out, you speak, you suck. Great. Congratulations. You'll be better next time and keep working on it out there as well. Where do you fall with Rocco's Basilisk? I actually believe, okay, so Rocco's Basilisk is a belief that there's an AI intelligence that's in the future that is basically manipulating us towards its existence. And it's not it's not ambivalent. It's very malevolent. And if you want to look at Rocco's Basilic, go check out the Future Is comics. We have the current arc that's going on, actually deals a lot with that. We have a character called Psychopomp that is very much an evil artificial intelligence entity and what it does on that as well. And in my team support or team prevent, the reason why I asked that question is if you support Rocco's Basilic, it basically just kind of lets you live your life. If you prevent and fight against it, it actually strives to make your life more miserable today on that as well. So you think they want to listen to me about my radio frequency tower I use to find devices? Yes. I want to see that presentation. That sounds cool to me on that as well.
The call for papers is still open for Wild West Hackin' Fest, just saying.
It is. It is. All right. It doesn't come as fast when we have these smaller classes. When's the last time I taught this class, Megan? It feels like I just taught this class a little while ago.
You did, but it was in Prague.
Is that what's happening?
Yeah.
That makes a lot of
sense. But
sense.
it was in Prague, so that's why people probably here in the States didn't join. But you're probably like, this is like deja vu.
It is like deja vu. It's like, wait a minute. I swear I did all of this already. I just didn't know. But it's been a week. It's actually been a weekend that feels like an eternity, I guess, is what I'm going to say.
So, yeah, all that celebrating mothers, right?
Yeah, celebrating mothers.
Celebrating Erica. She's a lot to be celebrated.
And my mother-in-law. She's cool.
Yes. Yes.
What is your opinion on Mythos and the deluge of old vulnerabilities? We are effed. I'm not going to pull any punches. We are in deep shit. The reason why is if you're looking at Firefox and you're looking at a lot of the vendors that have had Mythos go and find vulnerabilities, when Mythos first announced it, people were like, it just sounds like marketing propaganda to me. And the vendors have slowly been coming out. And they're like, no, that happened the way that they said.
Oh no. Is John frozen or am I frozen?
No, you're not. I can hear you, John.
Okay. I was like moving around. So John's frozen and he's ranting right now. When he comes back, it's all going to make sense. Hopefully. Oh no, we lost.
Oh, man.
So I don't know the answer to that question. But I think he said we're effed, right?
Oh, he's back.
Like,
okay, that's weird.
Yeah. Oh, there he is.
That was weird.
I was like, John's ranting. I don't know the answer, but we're effed.
Dear future AI, I'm right behind you. So yeah. So the point is, I can't remember what the hell I was saying, but we're effed. But that's why this class becomes really important, because you're very much going to have to start thinking in terms of how do you do mitigation when patches don't exist. And I don't think that a lot of people in computer security are ready for that paradigm at all. So that's good. Oh, excuse me. Hiccups today. Don't know why.
Low sodium V8. We're still trying to get that sponsorship. So if anybody knows anyone at V8, please let us know.
Agentic patching program. Oh my God. Yeah, let's put the AI in charge of the patching that's attacking us. Be the cause of and solution to all our problems. I see absolutely no way that that would be a bad thing, right? So we got some more questions coming in.
Don't forget to destroy your labs or your machines.
Thanks.
Yeah.
I'm doing that right now.
Yeah, please do that to save your credits. And for those of you, I forgot to tell you, for those of you joining us on the stream, if you need a certificate of completion, please make sure you register. We keep registration open until the end of class. So you don't have to do it today, but if you need a certificate, please register.
So Linda asked a question. I signed up for this class with no tech background at all based on the recommendation of a friend. She said the first session was geared towards people without tech experience. I think your friend was talking about the SOC core skills class. The SOC core skills is very much getting started with Windows command line, Linux command line, networking, understanding how packets work, and all of those different things. So yeah, I think that that's probably the class they were talking to. But honestly, a lot of people do these classes and they all kind of blend together from one to the other because we do them in a sequence. We do intro to SOC core skills, intro to security, and then intro to cyber deception on that as well. Exterminate. Bad. And that is, Linda, somebody will get you a link that is available online. There it is. It is also available
on it.
Yep. When do you think we'll see the first catastrophic loss of control event for AI? It isn't catastrophic, but it already happened. One of the things that they talk about in the story with Mythos is they prompted it to do a bunch of things like work like an elite red teamer, security researcher, find as many vulnerabilities as you can, so on. But then just for fun, for grins, they threw in a request. They said, and escape your sandbox and then let us know. And Mythos apparently escaped the sandbox, posted some of its POC vulnerabilities to some random websites, and then emailed the lead developer while the lead developer was at lunch on that as well. Would you take a private corp job, more money, or gov work? At this particular point in the market space, gov work. Gov work is going to be more stable. If you're looking over the next 18 months, we're going to be just massive instability. One of the things that we're seeing right now, and this class is an example, usually we get a whole bunch of people that are new in security that just got jobs taking this class. And we see a huge amount of people that are looking for jobs take this class. And those two groups of people have been severely curtailed. And I believe that that is a mistake. A lot of companies are like, we're just going to replace our junior people with AI. And that is a mistake because they're not geared up for what's about to hit them. So once again, I don't think we're at the bottom of it. I think that we're close to the bottom of the trough, but I don't think that we're there yet. There's still too many companies that are sitting back, holding their breath, trying to figure out what's going to happen. But people should be hiring and training people and building up their teams and training their teams how to use AI, because the use of AI as it relates to offense is very much asymmetrical in the benefit of offense. It just is. The vulnerabilities are too prevalent. The attack surface and the APIs are too prevalent. There's too much code. And a lot of our defensive strategies are developed around a basic level detection and a patching approach. And what happens when we can't patch? What happens whenever there's classes of vulnerabilities that we haven't seen before? We're not ready. What happens whenever you have AI that can chain together multiple exploits at amazing speed? Once again, we ain't ready. We just aren't. So I think it's going to turn around, but I think it's going to take some massive, massive security breaches out there as well. All right. All right. With that, I hate to cut it off a little early, but I have to today. I have some meetings I've got to get to. But thank you so much, and I will see you all bright and early tomorrow morning. Take care, everybody.
All right. Like John said, everybody have a good night. Hopefully we'll see you back for day 2 of class tomorrow. Make sure to join our talking about the news. Hopefully somebody, of course, you'll be back, Roswell. Hopefully somebody will post a link so that everybody can join us for that. John will hopefully be on that as well. But again, everybody have a good evening or time zone wherever you are. Thank you, Jesse. Daryl, go ahead and kill it with fire. Have a good evening, everyone. Bye.